Hello everyone, I'm Frank and welcome to Frank Puzzles. And this is today's very easy other type of puzzle. So this is supposed to be a different just a different type of puzzle. And it's called Trichroma Paintomino #1 by Maze Gator. And here are the rules. We need to divide each outlined region into 3 differently sized subgroups of cells. Then assign one of 3 colors to each group so that each region contains exactly one group of each color. So we could use the colors red, green, and blue, but each region that is every designated region here must be divided into 3 subgroups of different sizes. And a digit in a cell indicates the size of that cell's group. Or subgroup, actually, I think. Right? Subgroups that border one another through a bold region boundary may not be the same color or the same shape, counting rotations and reflections. So, for example, say this is 3. Well, this is kind of obvious what this is. So, this is 3 as a region, as a subregion. This 3 cannot be the same shape by rotation or reflection. So this could not be that shape here. It could be some other shape, but it's kind of obvious what shape it has to be. But anyways, I'll leave that to the solving. When the colors of the subgroups for each region are placed in order from largest to smallest, any pair of bordering regions must have a different order. When the colors of the subgroups for each region are placed in order from largest... Okay. So basically, right. So each region, again, is divided into 3 subgroups, and you have to have one of each color there. And they have to have a different... Does it say you have to have a different amount? It doesn't say that. Huh. Okay, so part of me is wondering, because the thing is, I think I read in the original post itself, that you have to have different amounts for each region. Let me double check that, actually. Well, I'll just take a look right now. Divide each outline region into 3 different... Yeah, this says differently sized subgroups of cells. That's actually very important to have. Oh, yeah, it just says that here. Yeah, 3 differently subsized... Okay, so yeah. Each of the regions, each of the subgroups in a region must be different sizes. So you cannot have multiple of the same size. Okay. And a digit in a cell indicates the size of that cell's subgroup, essentially. And when the colors of subgroups for each region are placed in order from largest to smallest, any pair of bordering regions must have a different order. So, okay. That means, say, this was size... you had green, red, and blue here. That means this could not... This would say this was this order of green is the largest, blue is the second, and red is the third largest, or is the smallest. That means you cannot have the combination of green, red, and blue in this region, since it's a bordering region, be exactly the same order. So that should tell you some information there. And those are all the rules. If you like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. Okay, for subgroups, we know this is size 3, so it has to be there. This has to be size 1, so it must be there. So we'll make this blue. We'll make, not red. We'll make this blue, we'll make this red, and we'll make this green. This is size 3. It cannot be the L or J shape. So it has to be 3 in a row, because it can't be this, it can't be here. It has to be this way. This is also going to be the largest size. So it can't be blue because it could be blue potentially. So this is blue or red. We know this is a subregion. We have to have either 2 or 1 here. So either this is 2 and that's 1, or this is 2 and that's 1. This digit, though, cannot be green. Because this touches both of them. This blue touches both 5 and 4 here. How large is this? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So we have to have a 1. And it cannot... 1 has to be blue. Well, this has to be 5. So that's a subregion. And this has to be another color. But blue can't be either of them because they are different in the different regions. So this is a combination of red and green. This cannot be the 1 because that would have to be blue. Orange can't get there, so this must be pink. But it can't be green, can't be blue, therefore this has to be red. And this must be green here, then. This can't be 1. It cannot be 4. Because 1 and 1 would be next to each other. This is a subregion. Cannot be green, it's red or blue. This can't be red or blue. Because if it's blue, it's blue and it's the same shape as a 1. So this has to be green. Oh, wait, no. Blue is 2 in size. Never mind. It could be any of these, then. It can't be blue here. Because that would force this to be size 5. So this has to be green. So that's definitely green. You cannot have blue here. So you could have blue here or blue here. Blue here would mean that's green and that's red. So this is guaranteed to be blue. So this is sub-boundary here. This could be blue or red. This has to be green or red, and this is blue or green. 4 cannot be the same shape, so this cannot be red that way. So this is not red. That's blue, which makes that blue. So this can't be blue. That's green. This can't be green. It's red. So this is subgroup here. So this is 3, 3. We have 4s here. This is 4. 2, 2. 5, 5, 5, and 5. These are 3. We don't know which ones these are. 2 is only going to be a 2-cell line. So 2 cannot be next to each other either. So this cannot be 2 going this way. It has to be 2 going that way. So then this is 2. This is 1. So we have 2 here. This is 1. Green cannot be any of these. So green has to be here. You could have 1, 2, and 5 here. That is possible. If you have 2 here, it would have to be 4 and 1. Hold up. Right, it's either 2 this way, that cannot be neighboring. So this can't be 2. So this has to be a 1. So this is 1, this is 2 and 2. And then these are 4. So this is 4. This cell cannot be the same as this and that, because it's neighboring both of them. So this is also green. Therefore, these two can't be the same color, because if they were, then this would have to be the same color as that, and they're neighboring regions, and they would have the same order from largest to smallest. So this will make, we'll make this yellow. This is pink, which makes this yellow here, and this pink. We don't know which. This is 1. We have 5 remaining here, which means 6 in the remaining cells. This is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So we have a size 4 region left. This is 1, 2, 3, 4, 5, 6, 7, 8, 9. They have to be different sizes, so it could be 1, 2, and 6. It could be 1, 3, 5, or 2, 3, and 4. This has to be a red cell because it's touching green and blue. So this is definitely red. These are both yellow. This cannot be size 1, so this must be part of this region, so that's red. Which means the yellows cannot be yellow. The yellows are blue, essentially, and pinks are red. Blue cannot be any of these, but red could be here. Okay. We don't know what size these are. Let's see. Blue cannot be here. Blue cannot be any of these. So blue could be any of those potentially. Blue cannot touch any of these. Or it could touch here. Blue can't be any of these. But, okay, so this is size 4, 5, 2 for this region. Blue cannot be any of these. So blue can't be here. So here we have red, blue, green. We have blue, red, green. We have blue, green, red here. And green, red, blue here. Okay. This is touching like all of them, isn't it? Yeah, it's touching every region. So therefore this... Okay. All the different combinations. Um... So red... What can red be here? So what are the combinations that we can have? We already have blue, red, green. We have blue, green, red. So that means this can never have blue as the largest region. We have red, blue, green. Aren't those... Oh, right. We have red, blue, green. And we have green, red, blue. So the only ones we can have here... So we can't have blue as the top one. Because we have as the largest. Because we already have blue, red, green, and blue, green, red. And those are blue as the top. What we're missing is red, green, blue, or green, blue, red. So red... Okay, so which ones then... Okay, so we have all the blues. So we have blue, red, green, and blue, green, red. What we don't have is red, green, and blue. Right? Red, green, and blue. Or green, blue, and red. That means red is either the smallest or it's the largest of this region. Interesting. Hmm. Okay. Um... Hmm. This only touches another region here. So this is blue or red. We don't know which. Uh, Green is either medium or it's the largest. So green can never be here. If green is here, it stops here, and then this would be size 2. Or this would have to be red 3, and that would be green 1. But again, we can't have that because the only possible combination of colors is either red, green, blue, or green, blue, red. And if this is 3 and 1 here, so green cannot be either of these. Because it would be the smallest in these scenarios. So these have to be both red. So red is going to be the largest. It's size 4 at least. So red's the largest. So red's the largest, green's middle, and blue's the smallest. Green can't be here, but it could be blue. Okay, so that's interesting. If this is red, it would go here, but then this would be the same shape if this is only 5. So either this is... Oh, it can't be 4 because that's the same shape as this. So this has to be greater than 4. Therefore, this is red and red because it can't be 5 because that would be the same shape. So this is 6, and it has to be 6, 1, and 2. So this is 6, 1, and this is this has to be 2 because it has to be green. And then this is some combination of 1 and 2 here. Interesting. This is 5, 2, and 4 here. This has to be 6 also. With 5. Right? We have 1. This is size 12. 1, 5, and 6. So this is red, green, blue. This is green, red, blue. So blue cannot be the smallest. Right? If blue were the smallest. So we have red, green, blue here. This is green, red, blue here. That means blue can never be the smallest here because both of them are accounted for in the neighbors. So this is not blue, that's red. That means 5 has to be green because you can't have green. Well, that's not true. So 5 could be blue here. Okay. This is blue or red. So what we know these are combinations of 5, 4, and 2. This cannot, these are different colors, so this both must be green, because we don't have a size 1 subgroup in this region. So it must be green, then that's green. Cannot go down here. It's at least size, it can't be size 2, because then it can't be by itself, so it's 4 at least. Green has to go this way. And it cannot go here because that would be neighboring it. This can't be green, that's blue, which makes this green. So that's 1, this is 2. And this cannot be size 4 because that would match this. So this must be size 5. So that's green. And this is size 2, the rest has to be 4. This cannot be blue, it's red, which makes this blue here and size 4. That's done here, done here. So these are 5. This is 2, and this is 4. This is red and green. This is red and green, so this cannot be red and green. It's blue. They have to connect here because it can't go all the way around. We have a 1 and 5 and 6. This is blue. This can't be green, so that's blue. This can't be green, so this has to be blue. So we have size 5 already. And it can't be part of this, so it must be 6. So all of these are green. And then the blue has to connect to one of these. It cannot be the same shape as this, so it cannot be here. So that's blue, and that's green. And so then this is size 5, and this is 6. And that's a solution. Fairly straightforward. Pretty interesting exercise, actually, about how these can interact. The coloring is a little bit difficult to keep in mind. The shapes are a little easier to see. I don't know if I would consider this very easy. The logic behind it isn't hard, but the execution can be pretty difficult, I feel. I don't know. Maybe it's just me. I would consider this more of an easy level puzzle, but still, it's pretty cool. It's a pretty interesting idea here. Anyways, I hope you enjoyed this solve, and I'll see you next time on Frank Puzzles. Take care.